Welcome back. This is an Aleks training video on calculating the heat of reaction for molar reaction enthalpy and the mass of a reactant. Alright, the title's scary. This is not so bad. I think you'll be okay with this. It's giving you a balanced equation. You see that some ammonia is going to break into nitrogen gas and hydrogen gas. And when that happens, it's going to be endothermic. So the test tube, if this happens in whatever way, is going to get cold. It's going to suck some energy out of the environment in order to do this reaction, because these guys, as gases, are going to have lots of energy because there's two different gases. This is one gas is going to have a smaller amount of energy. So in order for this to happen, you're going to actually have to suck some energy out of the environment for it to happen. And it's this much environment that gets sucked in. Okay, so it's a positive number. That's endothermic. A negative enthalpy is going to be exothermic. So your first question, this reaction is, if this is positive, it's going to be endothermic. That's your first one. That's easy. Okay. Then they're going to give you an idea of ammonia. If you have 94 grams, is heat going to be released or absorbed? Well, what does endothermic mean? It means there's less energy in the reactants, more energy in the products. So this heat has to come from the environment and get sucked in. So heat, if this reaction happens, is going to be absorbed. That's what endothermic means. Okay. Then they're going to ask you how much heat is absorbed. Okay, so here's where I'm going to have to give you this. I like this reaction because you're using a ratio. And it's the only math I ever learned in grade school was ratios. And the ratio is from the balanced equation. I can use this just like part of the balance. Remember I say that there's 2 moles of ammonia, 1 mole of nitrogen gas, or 2 moles of ammonia, 3 moles of hydrogen gas. I can make a relationship between the parts of this balanced equation. I can do the same with the enthalpy. I can say for every 2 moles of ammonia, 160 kilojoules of energy is absorbed. Every time there's 2 moles that breaks apart, that much energy is absorbed. That way, if they're going to give me some grams, I simply put it into moles and then relate it to 2. 2 is to 160 as whatever is to the next number. Okay, so I need to find out how many moles of ammonia 94.6 grams of ammonia is. So I need the molar mass of ammonia. So nitrogen is, there's 1 of them. Its atomic mass is 14.0067. Then hydrogen, there's 3 of them, 1.00794. That's going to equal 3.02382. 067. Add those together. Get 17.03052 grams per mole. Okay, that's good. Now I'm given grams. I just like changing pens. 94.6 grams. 1 mole is 17.03052 grams. Okay, so I need to divide that out. Going to equal 5.5547 moles. Okay, so now I can give a ratio. 2 moles of ammonia is to 160 kilojoules. 2 moles of NH3 is to 160 kilojoules of energy as 5.554 whatever. I'm going to round this up at the end, so it doesn't matter right now. That's probably enough. Moles of NH3 is to how many kilojoules of energy? All right, so it's going to be 160 times 5.554 divided by 2. Okay, I get 444.32. Now how many do I round to? I was given 3 significant digits, so I want to round to 3. Those go away, and you're going to get 444 kilojoules of energy. Okay. I like this one. I think I can do this one. The rest of them I'm not sure I can do, but this one's I like. I hope you love it too.